This is Unit 5, Lesson 1, Part 2. So we're going to be building on those polynomials that we learned about yesterday and doing some operations with them. So we're going to be adding and subtracting them, multiplying them, and then doing some very simple division. We'll have a separate lesson later where we build on the idea of what it means to divide polynomials. So the first section, adding and subtracting polynomials, we have just a quick two-step process here. You want to combine like terms, being especially careful for subtraction problems because you need to distribute that subtraction, and then make sure your answer is written in standard form. So we are going to start with number 2 here. So this is just addition. So you're looking just kind of combine like terms here. So 9n to the third, when you add that to this polynomial, there is no n to the third here, so that would just be 9n to the third, nothing else to add to it. For the n squareds, we have a negative 4n squared plus a negative 2n squared. So combine like terms, negative 4 and negative 2, we have negative 6n squared. Then we move to the 2n plus n. So 2n plus n would be 3n. And then finally the constants, we have a negative 10 plus positive 7, and that would be a negative 3. So this is in standard form. They're in descending order, 3, 2, 1, and then the constant. You may notice that there's a GCF. There's really nothing that we do with that. Like you can't divide out a 3, otherwise that would make it a totally different polynomial. Because it's an expression, you can't divide something out of an expression when there's no equal sign or no other side of that. So now let's do the subtraction. We want to be really careful with that. So I am going to actually distribute that subtraction and rewrite everything underneath. So we have y plus 4y squared minus 3, nothing changing there. But then I'm going to take the subtraction and distribute it to everything. So minus 1 minus a 2y squared minus a negative, so plus a 5y, and then minus a negative, so plus a y cubed. So now we're going to combine like terms. We want to make sure that our answer ends up in standard form, so we're going to look for the biggest exponent first. So our exponent of 3 is the biggest thing that we have, and that's actually the only y to the third. So we've got that. Then we look for y squareds. We have one right here and one right here, positive 4 and a negative 2. So that would be a positive 2y squared. So we don't have to worry about subtracting now because I already distributed the subtraction. We're just combining like terms. Then would be the y's. Here's a y. Here's a y. So we have positive y, positive 5y. That would be a 6y. And then finally we look for our constants. We have a negative 3 and a negative 1. That would combine to a negative 4. So this polynomial right here is our final answer. I also want to do number 5. So this is the same sort of idea. We're subtracting. We're just kind of writing it out as almost like a word problem here. So subtract this from this. That means this comes first, and then we're subtracting. So I want to give you guys a little bit of a visual of what we could do here. So we are subtracting. I'm going to line it up right underneath, kind of like you would do a normal subtraction problem. And I'm going to line up my like terms. So subtracting a negative 10ab, so I'm going to make sure that goes under the other ab, like that. A positive 7a squared, so that is going to go under the other a squared. Sorry, I'm sneaking that in there. And then a negative b squared, so minus b squared. So I am going to line this up, kind of combine my like terms. So 8b squared minus a negative, so plus b squared. So this would be a 9b squared. Then my next term, ab minus a negative, so plus 10ab, so that ends up being 11ab. And finally, negative 2a squared minus 7. So negative 2 minus 7 would be a negative 9a squared. And that's my answer. You want to make sure it ends up in standard forms. Remember, in standard form with multiple variables, you put them into alphabetical order and then decrease that way. So the a's should actually go first, which means the negative 9a squared should be listed first, then the one that just has the 1a, and then the one that doesn't have any a's. So this is technically what your standard form should be, is just a little reversal of those variables. So that's how you add and subtract. It's basically just combining like terms. You just have to be extra careful when there's subtraction involved. So next, we're going to move to multiplying. And multiplying is basically foiling, except we're doing some kind of advanced versions of foiling. So we're going to look at number 7 first. So you either distribute or foil. So we're going to do a little bit of each. These two get multiplied together, which means we foil. And then we're going to distribute this 2x and then keep moving through our steps. So foil these out. So start with 2x times 4. That's an 8x. Then outside 2x times negative 9x, so negative 18x squared. Inside 1 times 4. And last 1 times negative 9x. So you've got that. That's what we get when we FOIL these two out. And then distribute this negative 2x. Make sure you're actually carrying the sign through with it. So negative 2x times 3x would be a negative 6x squared. And negative 2x times 11 would be a negative 22x. So those are all of my terms here. Number 2 says combine like terms, and we can kind of add in this third step. You want to make sure it's in standard form, so we can just be conscious of that while we're combining up our like terms. So we want to make sure the x squareds go first. So we've got, here's an x squared, here's an x squared. So we can combine those up. That will be a negative 24x squared. Then we have x's, so there's an x right here, x right here, x right here. So we have 8 minus 9, that's a negative 1, and then a negative 22 would be a negative 23x when I combine those all up. And then the only constant I have is this 4 right here. So that would just be a plus 4 that I could tack on to the end. So final answer, everything combined up and written in standard form. Next, I'm going to do number 9. So this says that I'm taking this and I'm cubing it, which does not mean I get to just cube this and cube this. If there's addition in the middle, it means I have to write it out 3 times. Because cubing something means multiplying it by itself 3 times. So that is what I'm going to do. Okay, so we write it out 3 times like that. I'm going to start by multiplying these two together first. So you FOIL and then simplify as much as we can and then multiply by the third piece. So FOIL these out. 2c times 2c would be a 4c squared. Outside 2c times 5d would be 10cd. Inside I have basically that exact same thing again, so I get another 10cd. And last 5d times 5d would be 25d squared. So that's just this. And then I still have to multiply by 1 more copy. So this is gonna run over a little bit here. So let's combine these up first. So in the middle, I can combine up a 20 CD. Okay, so now let me remind you how this kind of super foiling works when I extend everything out. So I start with this one. I start with the 4c squared, and I distribute that to these two pieces. Then I move here, and I do the same. And then I move here and I do the same. So I'm gonna have a lot of terms at first and a lot of stuff that I can combine up. So starting with this 4c squared. So 4c squared times 2c would be 8c to the third. Then 4c squared times 5d, and that would be 20c squared times d. Then move to the next one. Move to this 20cd and distribute that. So times 2c would be 40. And I have CD times C, so that would be 2 copies of C and 1 copy of D. And then distribute this to the 5D. So 20 times 5 is 100. And I have CD times another D, so that would be 1 C and 2 Ds. And then finally move to 25D squared and distribute that. So 25D squared times 2C, so 25 times 2 would be 50. And I have a D squared times C, so that is 1 copy of C and 2 copies of D. And very last one, times the 5D. So 25 times 5 is 125. D squared times D would be 3 copies of D. So lots of terms there. Finally, I'm going to combine up my like terms and extend it a little into the bottom here. So C to the third, remember standard form means I go in alphabetical order, so I start with the C's. So this is the only C to the third, so I just have 8C to the third. Then I move to my C squared, so these two have the exact same variable part, so I can add those together, 20 and 40 would be 60 C squared times D. These two are the exact same, 1C and 2 Ds, so 150. And then finally, this one has no C's, and it's the only one, so it's just 125 D to the third. So very large numbers, kind of a complicated process there, but this is the polynomial that we end up with. All right, so next page, I'm going to look at number 11. So this is another multiplication problem. We'll kind of practice that like extreme foiling that we can do. So we just basically turn it into a distribution problem. So we're going to start with the x squared and distribute that all the way through. Then move to the 6x, then move to the negative 7. So start with the x squared and distribute that. So x squared times negative x squared would be a negative x to the 4th. X squared times negative 9x is negative 9x to the 3rd. X squared times negative 4 is negative 4x squared. So now we're done with the x squared. So now move to the 6x and distribute that. 6x times negative x squared would be negative 6x to the 3rd. 6x times negative 9x would be negative 54x squared. And 6x times negative 4 would be negative 24x. And then finally move to the negative 7, distribute that. So negative 7 times negative x squared would be positive 7x squared. Negative 7 times negative 9x would be positive 63x. And negative 7 times negative 4 would be a positive 28. So that is everything all written out. I have 9 terms, lots of things that I can combine. Standard form means starting with the biggest power, which is the 4th power. So this is actually the only one that I have. Then I move to the 3rd power. So I have negative 9, negative 6, so that's negative 15, and that's it. So negative 15x to the 3rd. Then the squareds, so negative 4, negative 54, so now I'm at negative 58. And then positive 7, so that takes me back up to negative 51 for the x squareds. The x's, I have negative 24 and a positive 63. So that ends up leaving me with 39. So 39x. And then this is my only constant, that 28. So big, long polynomial in standard form. So remember from the other day, we would call this a quartic polynomial. That's what this ends up being. I want to do number 12 as well, get a little story problem in here, a little geometry flashback. So this is the height of a trapezoid can be expressed as 2x plus 9, so this is the height, while the bases can be expressed here. So this is your base 1 and your base 2. So over to the side here, I'm going to remind you guys of the area of a trapezoid. It's 1/2 times the sum of the bases and then multiplied by the height. So we can put all our pieces together. So the area is 1/2 times the sum of the bases. So the first base was 3x minus 7, and I add that to x plus 5. We'll combine those in just a second. And then multiplied by the height, which is 2x plus 9. So combine everything up here. So add these all together. So 4x and then a negative 2, and then I'll multiply this in. Excuse me, I'm sorry. So I can distribute this 1/2. I get 2x minus 1. And then I have that last, the 2x plus 9. Okay, so this, I distributed the 1/2 to these two pieces, and then I'm multiplying by this 2x plus 9. So the 1/2 only multiplies to one of them, not both of them. Then I FOIL this out for my answer. So 2x times 2x is a 4x squared. 2x times 9, negative 1 times 2x, and negative 1 times 9. So final answer, just combine those middle terms. So I get 4x squared. This ends up being a 16x, and then minus 9. So that is the expression that represents the area of that trapezoid. Finally, our last category, dividing polynomials. There's a little catch here. It's only by a monomial. That's all we're going to do today. So like I said in the beginning, it's kind of this simpler version of dividing. We have a whole day dedicated to dividing polynomials by polynomials. So number 1, divide each term in the numerator by the monomial. So let's start with number 14. So take this and divide it by this. Then take this, divide it by this, and this divided by this. So 20x to the 3rd divided by 4x. So 20 divided by 4 is 5. X to the 3rd divided by x. Remember, you do that little subtraction rule, and we get x squared. Then move to the next term, this one right here. Negative 4 divided by 4 is just a negative 1. X squared divided by x is just an x. And finally, last term, negative 8 divided by 4 is a negative 2, and the x divided by x cancels. So this is what I get when I divide. Step 2, write your answer in standard form. So this is, because you've got descending powers, rewrite any terms with negative exponents. I don't have any, so this is my final answer. We're going to do the evens down here. So we're going to do 16 and then finish off with 18. So just one by one, we divide these. So 30 over 15 doesn't really divide, but it can reduce. So we can reduce it down by 6. So 30 over 12 reduces down to 5 over 2. C to the 8th over C to the 6th, or C to the 2nd, subtract, and we get C to the 6th. D to the 3rd over D would be D squared, minus, now let's move to the next term, 36 over 12 is 3. C to the 6th over C to the 2nd is C to the 4th, we subtract. D to the 2nd over D is just one copy of D. And finally, last piece, plus 6 over 12 doesn't divide, but it does reduce down to 1/2. C to the 3rd over C squared is C, and D over D just cancels. So standard form means alphabetically we look at the C's. They are in descending order, C to the 6th, 4th, 1st, and there are no negative exponents. All right, last one, number 18. So we are going to divide, reduce this piece right here. So 40 over 8, we can reduce those down. We can divide them down. 40 over 8 divides out to 5. M to the 3rd over M squared is just M, we subtract. N to the 4th over N to the 5th. When you subtract 4 minus 5, we get a -1, so we'll come back for that in a second. Minus 24 over 8 is 3. M to the 2nd over M to the 2nd cancels. And N to the 7th over N to the 5th. When you subtract, you get N to the 2nd. So standard form means we look at the M's. This has an M, this doesn't, so it is in standard form. Last little piece is we have to rewrite all terms with negative exponents. So this N to the -1st, only the N, has to get flipped down to the denominator. So these pieces stay because they don't have negative exponents. Just the N flips down. And then this piece is good. It doesn't have anything negative. So that's our final answer there.